everybody. So in this video, we're talking about quadratics in vertex form. Graph the following quadratic equation given in vertex form. So here, this is what we have. So let's talk a little about vertex form. So typically, you have something like this. Ax minus h quantity squared plus k. This is the standard form of an equation in vertex form. Now, h and k represent the coordinates for the vertex. So here, h and k, very important. A has a couple of values. That tells you your stretch or compress. If A is positive, the parabola opens up. If it is negative, it opens down. So that's a few key things right off the bat. So they ask us, does the parabola open up or down? Well, A here in this is, we can understand it as positive 1. So because it is positive, then we would say that it will open up. All right? Now they want to know the vertex. Now a very common mistake is for people to say, oh, well the vertex is 2, negative 1 because I have positive 2 here and negative 1 here. All right, you're half right. Your y value is correct. This sign is never going to change. You always take the opposite of what's inside. Remember, the rule is x minus h. So how could I get a positive right here? Well, that's because you had something like x minus negative 2. And then the two negatives gave you the positive, right? So this should be a negative here. If it were a positive value, it would just be x minus positive 2, so it would be minus. So something I always tell my students, just change the sign of whatever's in the parentheticals. Okay, so here, let's write that out. Our vertex is actually negative 2, negative 1. And then what's the equation of the axis of symmetry? Okay, well, the axis of symmetry is just what's the equation of the vertical line where my vertex is. Well, I'm already in vertex form. I know my vertex has an x value of negative 2. So my equation is just x equals negative 2. And now what I'm going to do is I'm going to plot this on the graph. So here we're going to go to our vertex, negative 2, negative 1. And we're going to put a dot here. And then we know it's going to open up, but we can actually be a little precise in our drawing because it's actually going to be really easy to plug in values. Let's start going to the right. Let's say I plug in negative 1 and I plug in negative 1 here. What's negative 1 plus 2? Well, that's 1. 1 squared is 1 and 1 minus 1 is 0. So at negative 1, we have 0, and whatever happens to the right, we know happens to the left because all parabolas are symmetrical. So I don't have to plug in negative 3 because it's 1 to the left. It's going to have the same value as y value 1 to the right. So if I go 2 to the right and I look at 0, 0 plus 2 is 2, 2 squared is 4, 4 minus 1 is 3. So at 0, I'm at 3, and I know that will be the same at negative 4. So we kind of see how this is opening up. And even if I went one more, if I went to 1, 1 plus 2 is 3, 3 squared is 9, 9 minus 1 is 8. At 1, we go all the way up to 8, and I know that'll be the same thing at negative 5. So here is my parabola. All right? Let's take a look at another problem with dealing with vertex form. All right, so here in this, they give us an equation as well, and they want us to find, again, the axis of symmetry, the vertex, and now they ask for the domain and the range. Here's a table we need to fill out, and we can use the table in order to graph our quadratic. Okay, so here we have x equals negative b over 2a. All right, well, how are we going to figure out what the b term is? Because a quadratic is written like this, ax squared plus bx plus c. So here, in order to find out the equation of the axis of symmetry, we have two options. You can do a whole bunch of math to get it in standard form, or the easiest thing, for axis of symmetry, it's just the x value of your vertex. And we know the x value of my vertex here is negative 3. So I can just say x equals Negative 3. That's a really big perk going from or working with the vertex form of a quadratic versus the standard form. Now, standard form is not bad because it's really easy to go from standard form to factored form to figure out what the zeros are. But when you're looking for other things like axis of symmetry and vertex, I think vertex form is very, very easy to use. All right? Now my vertex is going to be the opposite of this number, and then the k here stays the same. So this is going to be negative 3, negative 5. All right? Now, domain and range, this is very easy to answer once we have a picture of the graph. So let's fill out our table, and then let's graph, and then we'll come back and answer our domain and range. So here, for vertex, negative 3, negative 5, we now need to know what are the y values when I plug in negative 2, negative 1. So if I plugged in negative 2, what's negative 2 plus 3? Well, that's 1. 1 squared is 1. And then this now makes it a negative 1. And negative 1 minus 5 is negative 6. And whatever happens 1 to the right will also happen 1 to the left. Now I can plug in negative 1. Negative 1 plus 3 is 2. 2 squared is 4. This is now negative 4. Negative 4 minus 5 is negative 9. Now that I have a table of values, I can easily plot this. So negative 3, negative 5. This is counting by 2, so I want to make sure I'm paying attention to that. Negative 2, negative 6. That'll be the same for negative 4. And then at negative 1, we're at negative 9. Negative 1, 9 right here. So my vertex is going to open down. Not the vertex, excuse me, the parabola is going to open down like so. Now, domain. Will this graph go forever? So with domain, people always think, does the graph go forever left and forever right? Yes, that is true. But another way to think about it is, no matter, because domain, you really want to pay attention to your x values. So the better question, in my opinion, is, if I looked at positive 4, will I have a y value? Yes, because this graph is going to keep going. Like, I can go 0, I can plug in 0 and get a number. I can plug in 1, I can get a number. I can plug in 2, I can get a number. Even if I plugged in 1,000,000, if I plugged in 1,000,000 here, I would get a y value. So that's true all the way to the right and all the way to the left. So here for the domain, we're going to say all real numbers. Now, you can address this two ways. All real numbers like this, or you could put it in interval notation and say negative infinity to infinity. Here for the range, does the graph go forever up and forever down? Yes and no. It does not go forever up, but it does go forever down. So since the graph is traveling down, what's the highest y value? So where does the graph start? It starts at negative 5, and then it begins decreasing everywhere below negative 5. So here, for the y value, we're going to say y is less than or equal to negative 5 here, or we can say it goes from, we'll change that. This needs to be negative infinity and stops at negative 5. Remember, you can never put a bracket with parentheses, and the reason we put a bracket with negative 5 is because negative 5 is included in our range. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.